Good morning, my name is Denise. My metrics number is 23DBT 2005, and today we will be talking about the Bioflow bioreactor. So, on the first part, we will talk about the dissolved oxygen probe. The DO2 probe is used to measure dissolved oxygen in the fermentation broth. Next would be the sampling device. The sampling device is used to draw samples of fermentation broth from the bioreactor. The following would be the filter exhaust air. All exhaust air passes through a 0.22 micron filter to prevent the fermenting microbes from escaping into the environment. Next would be the airflow meter. The airflow rate dispatched into the bioreactor is set by this meter. The jacket water inlet. Cold water enters the bioreactor through the jacket water inlet located at the bottom of the glass jacket. The temperature sensor. The temperature of the broth is measured with a probe that is inserted into a well. Next would be the jacket water heater. This component is located at the base of the bioreactor and heats the water that is circulating through the glass jacket. Next, the water regulator and pressure gauge. This assembly is used to adjust the entering water pressure to within the rate pressure range of the glass jacket. Then the pH probe used to measure the pH of fermentation. Next would be the agitator that ensures proper mixing, the base pump pH, the jacket water outlet that's located in the glass jacket, the inoculation septum in the membrane that allows sterile injection. They will have the air cylinder, a large canister, and lastly a still bar. So now we will explore the common operations of the Bioflow reactor. The first one we will be looking at is process 1, which is to calibrate the dissolved oxygen probe. Step 1 would be to confirm that the air cylinder is open and air is sparging into the bioreactor before we begin. Next, step 2 would be select the DO2 key on the primary control unit, also known as the PCU touchpad. Next would be step 3, which is to select calibrate on the PCU. This will take us to the calibrate menu. Going on with step 4, which would be set 0 on the PCU touchpad to begin the calibration process. Next would be to enter the number 0 on the PCU touchpad, following with step 6, which is an important step. Before pressing the enter, we will need to disconnect the DO2 probe and wait until the raw input value stabilizes. Step 7 would be after the raw input value has stabilized, press enter to accept your 0 set value. So for step 8, we will now reconnect the DO2 probe, then select set span to continue. Step 9, we will enter the number 100 on the PCU touchpad. For step 10, after the raw input value stabilizes, hit the enter key. Step 11 would be select return to main on the PCU touchpad and finish the DO2 calibration activity. And lastly would be we have calibrated the DO2 probe. The next step would be set a specific water temperature using the set point. Step 1 would be selecting the temperature key on the primary control unit touchpad. Step 2 would be to select the set point on the PCU. This will take us to the set point menu. Next would be to enter 35 degrees Celsius on the PCU touchpad. Select enter to accept the new value. Step 5 would be select return to go back to the PCU main menu. Our set point activity is now complete. Next, we will move on to process 3, which is taking a sample with the Bioflow bioreactor. 1 would be to open the thumb clamp on the sample intake tubing. Step 2 would be to put on the syringe plunger to create a vacuum in the sample bottle. Step 3 would be to fill the sample bottle to within 25% and 50% full. Step 4 would be to pinch close the thumb clamp. Step 5 would be to remove the sample bottle by rotating counterclockwise. The following step would be to transfer the sample and replace the bottle. Next would be to unscrew the syringe before depressing the plunger valve. Then depress the plunger into the syringe to prepare for the next sample. Reconnect the syringe to the air filter. And lastly, we have completed the activity of taking the sample. The next process would be the airflow within the bioreactor. Step 1 would be air for the bioreactor is delivered from the pressurized air cylinder to the airflow meter. The fermenter requires the oxygen that is in the air. Step 2 would be to adjust the incoming airflow rate using the airflow meter. Step 3 would be air is then passed through the filter to sterilize the air before entering the bioreactor. Step 4 would be the sterile air enters the bioreactor through the sparger tube and is released as bubbles. Step 5. Air exits through the exhaust air filter to contain the microorganisms within the bioreactor. The airflow activity is now complete. Next is process 5, which is temperature control. Step 1. When the temperature of the bioreactor is above the set point, cooling water is added through the jacket by means of a solenoid valve. Next, when the temperature is below the set point, the jacket water heater comes on to heat the jacket water. Cool water comes from the faucet through a water regulator and pressure gauge to adjust the line pressure to a safe range. Cold water travels through the tubing to the solenoid valve. Step 5. The solenoid valve will open to control the flow of the water to the bioreactor based on the target set point. Step 6. Cold water travels to the jacket water inlet on the bioreactor. Next, the cold water enters through the jacket water inlet. Once the jacket is filled, excess water is expelled through the jacket water outlet. Step 9. The water is then discharged through the tubing to the sink. Increase the water temperature, select temp on the PCU menu and then press enter. Select set point on the PCU, this will take us to the set point menu. We then have to select a set point higher than the current temperature of the 36.1 degrees Celsius and then press enter. Step 13. The jacket water heater will activate until the target set point has been reached. Activity is complete.